Welcome to Diverse Thoughts. Here, we craft audiobooks, documentaries, and discussions that explore a vast tapestry of topics, stretching beyond the limits of imagination. From the wonders of science to the depths of history, we're here to ignite your curiosity and take you on unforgettable journeys. Today, we dive into a few-hour adventure with Isaac Newton, the genius who shaped science forever in his 20s, a tale of brilliance, discovery, and a young mind that changed the world. So, grab a seat, hit that like button, and let's begin this extraordinary story together. Introduction: The dawn of a genius. Imagine a quiet English countryside. The year is 1665, and a young man, just 22 years old, sits beneath the gnarled branches of an apple tree. The air is still, heavy with the scent of damp earth and blooming orchards. Suddenly, an apple drops, tumbling to the ground with a soft thud. Most would see it as nothing more than a fruit falling, a fleeting moment lost to the wind. But not this young man. In that instant, a spark ignites in his mind, a question, a curiosity, a relentless need to understand why. Why does the apple fall straight down? Why doesn't it drift sideways or float upward? And could that same force, that invisible pull, reach beyond the tree, beyond the fields, all the way to the moon itself? This is the story of Isaac Newton, a name you've likely heard, a figure etched into the annals of history as one of the greatest minds to ever walk the earth. But what you might not know is that the seeds of his genius, the ideas that would reshape science forever, took root when he was barely out of his teens. In his 20s, during a single, extraordinary period of isolation, Newton unlocked secrets of the universe that still govern our lives today, from the flight of a rocket to the glow of your smartphone screen. This audiobook, Isaac Newton, the genius who shaped science forever in his 20s, isn't just a tale of equations and experiments. It's a journey into the mind of a young man who dared to ask the biggest questions, a story of brilliance born in solitude, and a testament to how a single decade can change the world. So, settle in, hit that like button if you're ready, and let's travel back to the 17th century, to a time of plague, discovery, and a boy who would become a legend. A humble beginning, the child of Woolsthorpe. Isaac Newton didn't enter the world with the fanfare you might expect of a future giant. He was born on Christmas Day, 1642, or January 4, 1643, depending on the calendar you use, in a small stone farmhouse in Woolsthorpe, Lincolnshire, England. His arrival was anything but triumphant. His father, also named Isaac, had died 3 months earlier, leaving his mother, Hannah, a widow before her son even drew breath. Newton came into the world premature, so tiny that his mother later said he could have fit inside a quart mug. The odds were stacked against him from the start. Infant mortality was high, and a fatherless child in rural England faced a precarious future. Yet, against those odds, he survived. Woolsthorpe was a modest place, a cluster of stone cottages surrounded by rolling fields and grazing sheep. It was far from the bustling intellectual hubs of London or Cambridge, a world of farmers and laborious rather than scholars and philosophers. Newton's early years were shaped by this simplicity, but also by a profound loneliness. When he was just 3, his mother remarried a wealthy clergyman named Barnabas Smith, a man 30 years her senior. Hannah moved to live with her new husband in a nearby village, leaving young Isaac behind in Woolsthorpe to be raised by his maternal grandmother, Marjorie Ainscough. Imagine that for a moment, a toddler abandoned, in his eyes, by the one person he needed most. That sense of isolation, that early wound, would echo through Newton's life, forging a man who thrived in solitude but struggled with connection. As a boy, Newton was quiet, introspective, and fiercely curious. He wasn't the rough-and-tumble type you'd expect in a farming village. Instead, He spent hours tinkering, building sundials to track the sun's path, crafting miniature windmills powered by mice, or sketching intricate designs in the dirt. His hands were always busy, his mind always racing. Neighbors might have seen him as odd, a child more at home with his thoughts than with playmates. But those early creations hinted at something extraordinary. A mind that didn't just accept the world as it was, but sought to understand how it worked. School days, a spark ignites. By age 12, Newton's life took a turn. His mother, now widowed again after Smith's death in 1653, returned to Woolsthorpe with 3 new half-siblings in tow. She enrolled Isaac in the King's School in Grantham, about 7 miles away, hoping to give him a proper education. Grantham was a step up from village life, a market town with a grammar school steeped in Latin, Greek, and the classics. But Newton wasn't your typical student. He boarded with the Clark family, local apothecaries, and it was there, amid jars of herbs and bubbling concoctions, that his curiosity found new fuel. The Clark's attic became his playground, where he'd carve sundials into the walls or lose himself in books. At school, he was brilliant but unpolished. His teachers noted his knack for mathematics and mechanics, but he wasn't a social star. One story stands out, a clash with a bully who kicked him in the stomach. Newton, slight and wiry, challenged the boy to a fight and won, not with brute strength, but with sheer determination. Then, to prove his point, he outdid the bully in classwork too. It's a glimpse of the fire beneath his quiet exterior, a stubborn streak that would define him. Yet, just as he was finding his footing, his mother pulled him out of school at 15. She wanted him to manage the family farm, a practical choice for a widow with land to tend. Newton, though, was a disaster as a farmer. He'd let sheep wander off while he read under a hedge, or build water wheels instead of mending fences. His uncle, William Ainscough, and the Grantham schoolmaster saw the truth. This boy wasn't meant for plowshares. They convinced Hannah to send him back to school, and in 1660, at 17, Newton prepared for a new chapter, Cambridge University. Cambridge, the crucible of ideas. In June 1661, Isaac Newton stepped onto the cobblestone paths of Trinity College, Cambridge. He was 18, a sizer, a student who worked for his keep, serving wealthier classmates to pay his way. It wasn't glamorous. He emptied chamber pots and waited tables, a far cry from the genius we know today. But Cambridge was a revelation. The university buzzed with the ferment of the scientific revolution, a movement shaking the foundations of medieval thought. Copernicus had placed the sun at the center of the cosmos, Galileo had peered through telescopes at Jupiter's moons, and Kepler had mapped the planet's elliptical dances. These giants loomed large, and Newton arrived just as their ideas were taking root. His early years at Cambridge were unremarkable on the surface. He studied Aristotle's outdated physics, objects moving because they wanted to, the Earth as the universe's center, alongside Latin and theology. But Newton wasn't content with the old ways. In his spare time, he devoured newer works, Descartes' geometry, Wallace mathematics, Boyle's chemistry. He filled notebooks with frantic scribbles, teaching himself beyond the curriculum. His mentor, Isaac Barrow, the Lucasian professor of mathematics, saw potential in this awkward, intense young man. Barrow's lectures on optics and curves nudged Newton toward questions the textbooks couldn't answer. Then came 1665. Newton was 22, in his 4th year at Cambridge, when disaster struck. The bubonic plague, a shadow that had haunted Europe for centuries, swept through England with renewed fury. It crept from London's slums to the countryside, leaving death in its wake. By summer, Cambridge shut its doors, sending students home to escape the contagion. For Newton, this meant a return to Woolsthorpe, a forced retreat that would change everything. The Plague Years, a world in crisis. Picture England in 1665. Streets silent except for the creak of death carts, church bells tolling endlessly, families barricaded in homes marked with red crosses. The plague killed tens of thousands, a grim reminder of nature's power. For Newton, though, this chaos was a strange gift. Back at Woolsthorpe, he found himself alone again. His mother and siblings kept their distance, and the village offered little company. The farmhouse became his sanctuary, its attic and garden his laboratory. He was 22, untested, and free from the distractions of university life. This was no ordinary exile. While others prayed for survival, Newton turned inward. He walked the orchards, watched the stars, and filled page after page with ideas. The apple tree story, whether true or embellished by later tellers, captures the spirit of this time. Legend says he sat beneath it, saw an apple fall, and wondered, what pulls it down? Could that same force hold the moon in its orbit? It's a tale that's grown mythic, but even if the apple never fell that day, something clicked in Newton's mind. He began to see the world not as a collection of mysteries, but as a puzzle he could solve. This period, spanning 1665 to 1666, became his annus mirabilis, his year of wonders. At an age when most of us are still finding our footing, Newton laid the groundwork for calculus, gravity, and optics. He didn't have fancy equipment, just prisms, paper, and his relentless intellect. He worked in near secrecy, sharing little with the world. Yet, these months in isolation would ripple outward, shaping science for centuries. The man and the moment. Who was this 22-year-old poised to rewrite history? Physically, he was unimposing, slight, with sharp features and a mop of dark hair. His eyes, though, burned with intensity, as if they could pierce through the fabric of reality. He was a loner, prone to fits of temper and obsession. Friends were few. His world was one of ideas, not people. Later in life, he'd feud bitterly with rivals like Robert Hooke and Gottfried Leibniz, but in his 20s, his battles were internal, against the limits of knowledge itself. The 17th century was the perfect stage for him. It was an age of upheaval. The English Civil War had just ended, the monarchy was restored, and science was clawing its way out of superstition. Alchemy mingled with astronomy, and scholars debated whether the earth moved or stood still. Newton arrived at this crossroads, armed with a mind that could bridge the old and the new. His 20s weren't just a phase, they were a crucible, forging a genius who'd give us the tools to understand the cosmos. What lies ahead? This audiobook will take you deep into that crucible. Over the next 10 chapters, we'll explore how Newton's 20s unfolded, his breakthroughs in calculus, optics, motion, and gravity, his rise at Cambridge and the Royal Society, the quirks and rivalries that defined him, and the legacy that still touches us today. Each chapter will peel back a layer of his story, blending science with drama, wonder with humanity. You'll hear about the prism that split light into rainbows, the equations that launched ships to the stars, and the man who forgot to eat because he was too busy thinking. For YouTube listeners, this isn't a dry lecture. It's a tale of a young dreamer who turned a plague into a triumph, a reminder that genius can strike anywhere, anytime, even in your 20s. So, stick with us. Subscribe if you haven't, and let's dive into the mind of Isaac Newton, the genius who shaped science forever, starting with a single apple and a question that wouldn't let go. Chapter 1. The Plague Years, Isolation and Inspiration. The summer of 1665 hung heavy over England like a dark shroud. In London, The air buzzed with the drone of flies and the faint, mournful creak of wooden wheels rolling through cobbled streets. Death carts lumbered past houses where red crosses slashed across doors, a grim warning of the terror within. The bubonic plague had returned, a spectre from centuries past, its claws sinking deep into the city's heart. Men in tattered cloaks, their faces shadowed by wide-brimmed hats, called out in hollow voices, "Bring out your dead," as families wept behind shuttered windows. The sickness spread like wildfire, flea to flesh, breath to breath, turning skin black with sores and lungs into drowning pools. By June, thousands had fallen, and the stench of decay clung to every corner of the capital. 50 miles north, in the university town of Cambridge, a young man named Isaac Newton felt the ripples of this chaos. He was 22, a student at Trinity College, his sharp eyes and sharper mind already restless with questions the dusty lecture halls couldn't answer. Cambridge was no London, but it wasn't safe either. The plague slithered closer, carried on the boots of travelers and the whispers of merchants, until the university's masters could ignore it no longer. In July, they bolted the gates, cancelled classes, and sent everyone home. Newton gathered his things, a few worn books, a notebook thick with scribbled thoughts, a prism tucked into his satchel, and turned his back on the stone towers of Trinity. He was heading home to Woolsthorpe, a speck of a village in Lincolnshire where he'd been born, a place so quiet you could hear the wind rustle the grass. The road to Woolsthorpe was a tense, lonely trek. Newton walked much of it, his slight frame hunched against the summer heat, or rode a borrowed horse when he could. Villages along the way were husks of themselves, doors barred, fields untended, church bells tolling a ceaseless dirge. He passed a cottage where a woman's wail pierced the silence, a child lost to the fever. Another mile, and he saw a farmer burning a pile of clothes, the smoke curling upward like a prayer for mercy. This was England in 1665, a land holding its breath, waiting for the shadow to pass. For Newton, though, it was something else, a doorway opening, a chance to step away from the world and into his own. Woolsthorpe Manor greeted him with the familiar sight of its grey stone walls, weathered and sturdy against the rolling green hills. It was no grand estate, just a farmer's house, its low ceilings and narrow windows keeping out the light as much as the plague. Inside, the floors creaked under his boots, and the hearth glowed weakly with a fire his mother, Hannah, kept burning. She was there, older now, her face lined with the years since she'd left him as a toddler to be raised by his grandmother. Her 3 younger children, his half-siblings, hovered nearby, but they kept their distance. The plague made everyone a stranger, even family. Newton didn't mind. He'd always been a solitary soul, more at ease with his thoughts than with people. He climbed the narrow stairs to the attic, a slanted space beneath the roof where he'd slept as a boy, and claimed it as his own. This would be his haven, his laboratory, his world for the months to come. Days at Woolsthorpe settled into a rhythm as steady as the ticking of a clock, if he'd had one to listen to. He woke with the dawn, the chill of the wooden floor seeping through his socks, and ate sparingly. Bread, a bit of cheese, though he often forgot meals entirely, his mind too busy to notice hunger. The house was quiet, save for the occasional bleat of sheep beyond the garden or the rustle of leaves in the breeze. He'd step outside, the air sharp with the scent of damp earth and ripening fruit, and wander to the orchard, a cluster of apple trees his family had tended for years. Their branches sagged with green and red orbs, and Newton would pace beneath them, his hands clasped behind his back, his dark hair falling into his eyes as he thought. It was here, under one of those trees, that the story we all know, or think we know, took shape. Picture it, late summer, the sun slanting through the leaves, casting dappled shadows on the grass. Newton sits, leaning against the rough bark, a notebook open on his lap, quill poised above a page already crowded with numbers and sketches. An apple, heavy with ripeness, breaks free from its stem. It rustles through the branches, a soft whisper of leaves, and lands with a thud at his feet. Most would see it as nothing, a fruit to pick up or kick aside. But Newton wasn't most people. He stared at it, his brow furrowing, his mind racing. Why did it fall straight down? Why not drift sideways or float upward? What pulled it to the earth with such certainty? The tale of the apple has grown into legend, polished by time and retelling. Newton himself never claimed it hit him on the head. That's a flourish added later, a neat little bow on a messy truth. But years after, as an old man sipping tea with a friend named William Stukely, he'd recall those days at Woolsthorpe. "I was sitting in the garden," he said, "and an apple fell, and it set me thinking, why does it fall perpendicularly? Could that same force reach the moon? So let's imagine it anyway, because the spirit matters more than the facts." He picks up the apple, rolls it in his hand, feels its weight. His eyes flick upward, past the tree, to the pale crescent of the moon hanging in the daytime sky. A connection sparks, faint, unformed, but alive. Could the pull on this apple be the same force tethering the moon to Earth, like a child's ball on a string? It's not a full theory yet, just a whisper of an idea, but it's the kind of whisper that changes everything. That moment wasn't a single flash of genius, though. Woolsthorpe wasn't a place of sudden epiphanies. It was a slow burn, a crucible where Newton's mind could stretch and wander. He'd spend hours in the attic, hunched over his table, the candlelight flickering across pages as he scribbled. His tools were simple, the books he'd brought from Cambridge, Descartes, Kepler, Wallace, a prism he'd toy with later, and a brain that refused to rest. The plague had taken the world away, but it had given him something rare: time. No lectures to attend, no classmates to dodge, no chores to interrupt. Just him, the quiet, and the questions that gnawed at him like a dog with a bone. Days turned to weeks, and the apple's fall lingered in his thoughts like a melody he couldn't shake. He'd pace the garden again, muttering to himself, his boots wearing a faint path in the grass. The question wasn't just why the apple fell, it was bigger, wilder. He'd look up at the sky, squinting against the sun, and picture the moon drifting in its endless circle. Back in Cambridge, he'd read Kepler, who'd mapped the planets' paths, and Galileo, who'd watched the moons of Jupiter. They'd hinted at order, at rules, but no one had tied it all together. Newton felt the itch of something unfinished. He'd sit again, the apple tree's shade cool against his back, and let his mind chase the thread. If the earth pulled the apple, could it pull the moon too? And if it did, how far did that pull reach? To the stars? To everything? Inside the attic, the real work began. One evening, as the light faded and crickets chirped beyond the window, he pulled out his notebook and flipped to a fresh page. The apple was a clue, but it needed proof, numbers, not guesses. He'd always been good with figures, better than anyone at Cambridge, even if he'd kept it to himself. He started sketching, a circle for the Earth, a smaller one for the moon, a line between them. He knew the moon took about 27 days to orbit, and he'd heard rough estimates of its distance, hundreds of thousands of miles, far beyond the orchard. If the apple fell fast, say, a few feet in a second, how weak would that pull be by the time it reached the moon? He scribbled, crossed out, scribbled again. The idea was slippery, but he wouldn't let it go. Then came the leap. He remembered something from his books, how light dimmed with distance, weaker the farther you stood from a candle. Maybe this force worked the same way, fading as you moved away. He tried a guess. What if it dropped off as the square of the distance? Double the distance, and it's a quarter as strong. Triple it, and it's a ninth. He scratched out a rough calculation, using the Earth's size and the Moon's orbit. It wasn't perfect, his numbers were off, the measurements too crude, but it fit close enough to make his heart race. The apple's fall and the Moon's dance weren't separate, they were one. He leaned back, the chair creaking under him, and stared at the page. This was gravity, though he didn't call it that yet. Just a force, a pull, a secret the universe had whispered to a 22-year-old in a quiet garden. But that wasn't all. Woolsthorpe wasn't just about apples and moons, it was a forge for something even stranger. Back in Cambridge, Newton had wrestled with problems that stumped him. How do you measure a curve that never stops changing? Planets didn't move in straight lines, they sped up, slowed down, traced ellipses across the sky. The old geometry of Euclid, all rigid lines and perfect circles, couldn't keep up. One afternoon, as rain pattered against the attic roof, he sat with a book by John Wallis, a mathematician who'd toyed with infinite sums. Newton's mind latched onto it. What if you could break a curve into tiny pieces, so small they almost vanished, and add them up? Or track how fast a line bent at any point? He grabbed his quill, the ink smudging under his fingers, and started writing. He called it fluxions, a word he made up, a way to capture the flow of things. Imagine a ball rolling down a hill, speeding up as it goes. How do you measure that speed right now, not later? Newton figured it out. You draw a line that just touches the curve, a slope that shows its tilt at that exact moment. He sketched it, a wobbly arc, a straight line kissing it at one spot. That was the fluxion, the seed of what we'd later call a derivative. Then he flipped it. What if you wanted the area under that curve, like the space a planet sweeps in its orbit? He broke it into slivers, added them up, and watched the numbers pile into something new, an integral, though he didn't name it that. It was messy, wild, but it worked. He tested it on simple shapes, then harder ones, and grinned as the answers clicked. The story flows on, unbroken, as Newton's isolation deepens and his ideas bloom. The attic becomes a cave of wonders, its walls closing in as summer fades to autumn, then winter. He barely notices the seasons. His world is the paper beneath his hands, the sky beyond his window. The fluxions consume him. He sits one night, the candle burned to a stub, and pushes further. What if you didn't just measure a curve once, but over and over, watching it shift? He invents infinite series, breaking a problem into endless tiny steps, each one adding to the last. It's like zooming in on the universe, peeling back its layers. He tries it on a circle, then an orbit, and the numbers dance. This isn't just math, it's a key to unlock motion itself, a tool to track the stars or a cannonball's arc. He's 23 now, and he's rewriting the rules, alone in a house no one else cares about. Outside, the plague still rages, but Newton's untouchable. He paces the garden again, the apple trees bare as November bites. The moon hangs low, full and silver, and he stops to stare. The fluxions and the apple force, they're connected, he knows it. He'd guessed at the inverse square law, but now he wants to test it. He digs into his books, pulls rough figures. The Earth's radius, the moon's distance, the pull he'd felt with the apple. He calculates how fast the moon falls toward Earth to stay in its orbit. Not plummeting, but curving just enough. The numbers don't match perfectly. His data's shaky, the Earth's size a guess, but they're close. He mutters to himself, It's there, it's got to be. He imagines the force stretching outward, tugging at every star, every speck of dust. It's not just the moon, it's everything. Winter blankets Woolsthorpe in frost, and Newton's habits grow stranger. He forgets to eat for days, his mother banging on the attic door to remind him. He sleeps in snatches, waking with ideas that send him scrambling for his quill. One morning, he stands at the window, breath fogging the glass, and watches snowflakes drift. They fall like the apple, he thinks, slow, steady, pulled by that same force. He sketches again, linking the apple's drop to the moon's orbit with his fluxions. It's rough, unpolished, nothing like the grand laws he'll publish later, but it's alive. He feels it, a truth bubbling up, a glimpse of the universe's machinery. Spring creeps in, 1666 dawning with a fragile hope. The plague loosens its grip, but Newton stays put. He's not done. The attic's a mess, papers strewn across the floor, ink stains on his fingers. He's obsessed now, chasing the threads. The fluxions let him measure change, apples falling, planets spinning, and the force ties it together. He sits one afternoon, the orchard greening outside, and writes a flurry of equations. They're raw, incomplete, but they sing to him. He imagines Kepler's ellipses, Galileo's pendulums, all bending to his math. This is his superpower, forged in silence while England mourned. Months blur into a year, and Newton barely notices. He walks the garden at dusk, the air thick with blossoms, and stops under that apple tree. The fruit's back, dangling like a promise. He plucks one, bites into it, and grins, a rare flash of lightness. The world's still out there, dying and healing, but he's found something eternal. He looks up, the stars piercing the twilight, and knows he's onto something bigger than Woolsthorpe, bigger than Cambridge. The plague took lives, but it gave him this, a year to dream, to wrestle with the cosmos. One night, as summer 1666 fades, he steps outside, the air cool and sharp. The village sleeps, the manor dark behind him. He stands alone, the grass damp under his boots, and gazes at the sky. The moon glows, the stars wink, and he feels them pulling, earth to moon, moon to stars, an invisible web has begun to unravel. He's 23, a nobody to the world, but in his head, he's holding the universe. The apple, the fluxions, the force, they're pieces of a puzzle he'll spend years fitting together. For now, though, he breathes deep, the quiet wrapping around him like a cloak. This is where it started, a boy, a tree, a question. And it's only the beginning. The story ends with him turning back to the house, the candle still burning in the attic, a light no plague could snuff out. Stay with us, the narrator says, because Newton's 20s are just warming up. Hit that subscribe button. This genius has more to show you. Chapter 2. Calculus, the language of the universe. The attic of Woolsthorpe Manor creaked under the weight of a restless summer night in 1665. Isaac Newton, just 22, sat hunched over a rickety wooden table, the air thick with the scent of melted wax and ink-stained fingers. A single candle flickered, casting jagged shadows across the slanted walls, its light barely reaching the corners of the cramped space. Outside, the world was silent. Woolsthorpe's fields lay still under a blanket of stars, the village holding its breath as the plague ravaged England beyond its borders. But inside this attic, a storm was brewing, not of wind or rain, but of ideas, wild and untamed, swirling in the mind of a young man who couldn't stop asking questions. The apple had fallen days ago, maybe weeks, sparking thoughts of a force that tied Earth to moon. That was big, breathtaking even, but it wasn't enough. Newton needed more, a way to prove it, to pin down the universe's secrets with something sharper than guesses. And so, As the candle burned low, he turned to a problem that had nagged at him since Cambridge. How do you measure a world that never stands still? Picture him there, his dark hair falling into his eyes, his thin frame swallowed by a worn shirt. The table's a mess, papers strewn like autumn leaves, some crumpled, others crowded with numbers and jagged lines. His quill scratches furiously, pausing only when he squints at a book propped open beside him. John Wallis's Arithmetica Infinitorum, a dense tangle of mathematics he'd borrowed from Trinity's library. Wallis had toyed with infinity, breaking shapes into endless pieces to find their secrets. Newton had read it back in Cambridge, half awake in his sizer's quarters, but now, in the quiet of Woolsthorpe, it hit him like a thunderclap. The universe wasn't static. Planets spun, apples fell, rivers flowed. Everything moved, changed, bent in ways the old geometry of straight lines and perfect circles couldn't grasp. Euclid was dead, Aristotle useless. Newton needed a new language, one that could dance with motion itself. He leaned back, the chair groaning under him, and rubbed his eyes. The attic was stifling, the air heavy with the day's heat, but he barely noticed. His mind was elsewhere, chasing a curve, a line that twisted and turned, like the path of a bird in flight or the arc of a cannonball. Back in Cambridge, he'd sat through lectures on tangents, lines that just kissed a curve at one point, showing its slope. But those were snapshots, frozen moments. What about a curve that kept shifting, speeding up, slowing down? How do you measure its tilt right now, not yesterday or tomorrow? He grabbed a fresh sheet, his hand trembling with excitement, and sketched a wobbly arc beside it. He drew a straight line, touching the curve at one spot. A tangent, yes, but more. This was the key, the first step to cracking motion's code. He called it a fluxion, a word he plucked from thin air, scribbling it in the margin with a flourish. It sounded right. Flow, flux, something alive. Imagine a ball rolling down a hill, picking up speed as it tumbles. You could clock it at the bottom, sure, but what about halfway? Newton's fluxion was like a magic trick. It froze the ball's rush at any instant, showing how steep its path was right then. He drew another curve, tighter this time, and tried it again. The tangent shifted, steeper here, flatter there. He scribbled numbers, distances shrinking, time slicing thinner, until the slope popped out, clear as day. His heart raced. This wasn't just a trick, it was a window into change itself. But he didn't stop there. Woolsthorpe's quiet wasn't just a refuge, it was a forge, hammering his thoughts into shape. The candle sputtered, wax dripping onto the table, and he lit another without a glance. The fluxion gave him slopes, but what about the space beneath a curve? Think of a planet sweeping through its orbit. Kepler had traced those paths, ellipses stretching across the sky. How much ground did it cover in a day, a month? Newton flipped his thinking. If fluxions tracked how fast a curve changed, could he reverse it? Pile up those changes to measure the whole? He sketched a jagged shape, a curve swooping over a line, and imagined slicing it into strips, thin as whispers. Add them up, he thought, and you'd have the area, the total sweep of a planet's dance or the path of a falling stone. He scratched out a sum, then another, his quill tearing the paper in his haste. The strips got smaller, thinner, until they blurred into a haze, an infinite pile. Wallis's trick turned inside out. It worked. He tested it on a simple curve, a hill-shaped arc, and the numbers lined up. Then a harder one, a wave that dipped and rose, and it held. He called this the inverse fluxion, though later generations would name it the integral. Together, these two, fluxions and their reverse, were a pair of wings, letting him soar over problems that had stumped scholars for centuries. He leaned back again, a rare grin tugging at his lips. This was his, born in an attic while the world crumbled outside. Days bled into nights, and Newton barely noticed. He'd stumble downstairs sometimes, his mother banging a pot to remind him to eat, her voice sharp with worry. "Isaac, you'll waste away up there," she'd call, but he'd wave her off, a chunk of bread in hand, and climb back to his cave. The attic was a mess now, papers spilling onto the floor, ink pots tipped over, a prism glinting in the corner where he'd tossed it. He'd sleep in fits, slumped over the table, waking with ink on his cheek and a new idea burning. The plague was a distant hum, England's death toll climbing, but Woolsthorpe was his bubble, and he was its king. One afternoon, as rain tapped the roof, he pushed further. Fluxions were a start, but they were clumsy, each curve a new fight. He remembered Wallace again, those infinite sums that stretched forever. What if he could break a curve into pieces so small they vanished, then rebuild it? He grabbed a circle, simple, perfect, and tried it. He wrote a series, a string of terms shrinking with each step. 1, plus a half, plus a quarter, plus an eighth. It grew, inching toward a number he knew from Cambridge. Pi, the circle's magic ratio. He kept going, terms piling up, until it clicked. This was a shortcut, a way to tame curves without wrestling them one by one. He called it an infinite series, and it was like a skeleton key, unlocking doors he hadn't even seen yet. He tested it on motion. Take that apple from the garden. How far did it fall in a second, 2 seconds? He sketched its drop, a curve bending sharper as it sped up. The fluxion gave him its speed at any moment. The series let him track the whole fall, step by tiny step. He scribbled, crossed out, scribbled again. The numbers danced, matching what he'd seen with his own eyes. Then he turned to the moon, that pale ghost haunting his thoughts. If it fell toward Earth to stay in its orbit, could he measure that curve too? He fumbled with rough figures, the moon's distance, its 27-day loop, and tried his series. It was messy, the data too crude, but it hinted at something real. His breath caught. This wasn't just math, it was the universe talking back. The story flows on, Newton's attic glowing with the heat of discovery as summer fades to autumn. He's 23 now, the plague still gnawing at England, but he's lost in his own world. The infinite series becomes his obsession. He sits one morning, the dawn light creeping through the window, and tackles a tougher curve, an ellipse, like Kepler's planetary paths. He breaks it into terms, each one smaller, and watches them build. It's slow, painstaking, but the shape emerges, its area unfolding like a flower. He grins again, a flicker of triumph. This is power, taking the wild twists of nature and pinning them to a page. He paces the attic, boards creaking under his boots, and thinks bigger. What about a cannonball fired into the sky? It soars, slows, falls, a curve that bends with time. He sketches it, a lazy arc, and applies his fluxions. The slope shifts, steep at the launch, flat at the peak, steep again as it drops. He calculates its speed at the top, 0, a perfect pause, then tracks its fall. The series piles up the distance, matching what he'd guess from watching apples tumble. It's not just theory, it's real, something you could test with a cannon and a field. He imagines armies using this, ships aiming their guns, and feels a shiver. His attic scribbles could move the world. Autumn deepens, the air turning crisp, and Newton's mind leaps again. He's not content with single curves, he wants the rules behind them. One night, the candle nearly gone, he sits with a stack of pages, linking his fluxions and their inverses. He draws 2 curves, one growing, one shrinking, and sees it. The slope of one matches the area under the other. It's a dance, a perfect mirror. He writes it out, a tangle of symbols, and stares. This is the heart of his method, what later scholars will call the fundamental theorem of calculus. It ties the instant to the whole, the now to the forever. His trembling now, not from cold, but from awe. This is the universe's heartbeat, and he's the first to hear it. Winter settles over Woolsthorpe, frost rhyming the windows, and Newton's habits grow wilder. He forgets days, his mother's shouts echoing up the stairs. "Isaac, come down," she'd plead, but he'd mumble something about bread and stay put. The attic's a chaos of papers, a map of his mind, curves, series, equations spilling everywhere. He tests his method on everything. A pendulum swinging, a river's flow, the moon's orbit again. Each time, it holds, rough, unpolished, but true. He imagines Galileo's experiments, Kepler's laws, all bowing to his math. This isn't just a tool, it's a language, one that speaks to stars and stones alike. Spring 1666 tiptoes in, the plague loosening its grip, but Newton's still lost in his attic. He sits one afternoon, the window open to a breeze thick with blossoms, and reflects. The apple's fall had sparked a force. This math gave it wings. He scribbles a final test, a planet's orbit, an ellipse bending under that pull he'd guessed at. His fluxions track its speed, the series maps its sweep. It's not perfect, his numbers are guesses, the force still fuzzy, but it's close enough to make him laugh, a rare, sharp sound. This is his gift to the world, born in a year of death while he hid away at 23. The real magic, though, isn't just the math, it's what it means. Imagine a ship sailing the ocean, its captain plotting a curve to dodge a storm. Newton's method could chart it. Or a bridge arching over a river, his series could measure its strength. He sees it dimly, a future where his attic scribbles lift humanity higher. He steps outside one evening, the sky bruising purple, and looks at the stars. They're moving, he knows, spinning in curves his math can catch. He's not done, he'll refine this later, fight over it with Leibniz, publish it in the Principia. But the seed's here, planted in Woolsthorpe's silence. Summer 1666 creeps closer, and Newton knows his time alone is waning. Cambridge will call him back soon, the plague fading like a bad dream. He sits under the apple tree again, the fruit ripening anew, and flips through his notebook. Pages of fluxions, series, tangents, a language no one else speaks yet. He's 23, a loner in a farmhouse, but he's cracked something eternal. The world's still out there, rebuilding, but he's given it a tool to touch the sky. He bites into an apple, the juice sharp on his tongue, and smiles. This is his annus mirabilis, his year of wonders, and it's only the start. The story ends with him standing in the garden, the attic light glowing behind him, a beacon of genius in a world waking up. Stick around, the narrator chimes, because Newton's 20s have more to unleash. Hit that like button, this is just the beginning. Chapter 3, Optics, the Spectrum of Light. The attic of Woolsthorpe Manor glowed faintly in the late summer of 1665, a sliver of sunlight sneaking through a crack in the shuttered window. Isaac Newton, 22 years old, sat cross-legged on the creaking floorboards, his thin fingers cradling a small, triangular piece of glass, a prism he'd carried from Cambridge in his battered satchel. The room was a chaos of papers and ink pots, the air thick with the musty scent of old wood and the sharp tang of melted wax from a candle burned to a stub. Outside, the world was a graveyard, England gripped by the plague, Woolsthorpe's fields silent under a sky that seemed to hold its breath. But here, in this cramped space, Newton was alive, his sharp eyes glinting with a curiosity that refused to dim. He'd already wrestled with falling apples and the moon's pull, scribbled pages of fluxions that danced with motion. Now, as the afternoon light filtered through the dust, he turned to something new, something shimmering, elusive, and utterly ordinary: light itself. He held the prism up, turning it slowly, watching the way it caught the sun's rays and bent them into faint, fleeting colors. Light had always been there, flooding the orchard, painting the sky, guiding his quill across paper, but he'd never really seen it until now. Back in Cambridge, he'd sat through lectures on optics, half listening as professors droned about Aristotle's idea that light was a pure, simple thing, or Descartes' notion that it rippled like waves in a pond. None of it satisfied him. The questions gnawed at him. Why did rainbows arc across the sky after a storm? Why did a diamond sparkle with hues no painter could match? He'd brought the prism home on a whim, a toy to tinker with, but as he sat there, the attic his kingdom, he decided it was time to find out. He stood, the floor groaning under his boots, and moved to the window. The shutters were old, warped, letting in just enough light to play with. He pried one open a crack, a thin beam slicing through the gloom, dust motes swirling like tiny stars. He held the prism in the path, tilting it until the light struck its face, and there it was. A splash of color erupted on the wall, a ribbon of red, orange, yellow, green, blue, indigo, violet, stretching across the rough plaster like a painter's dream. He froze, breath caught in his throat. This wasn't a trick or a fluke, it was real, repeatable, a secret spilling out of the glass. He tilted the prism again, and the colors shifted, widened, sharpened. His heart thudded. White light, the everyday glow he'd taken for granted, wasn't one thing, it was many, a chorus of hues hiding in plain sight. He scrambled for his notebook, knocking over an ink pot in his haste, the black stain spreading like a shadow he ignored. He sketched the beam, the prism, the spectrum, his quill scratching a frantic rhythm. This was no rainbow like the ones he'd seen after rain. These colors were crisp, ordered, a pattern he could control. He shut the window, plunging the attic into near darkness, and lit a fresh candle. The flame was weaker, but it'd do. He held the prism to it, and the colors bloomed again, fainter but still there, red bleeding into orange, blue fading to violet. He grinned, a rare flash of teeth in his usually somber face. Light wasn't pure or simple, it was a puzzle, and he'd just found the first piece. Days at Woolsthorpe blurred into a fever of experiments. He'd wake with the dawn, the attic chill seeping into his bones, and stumble downstairs for bread his mother left out, though half the time, he'd forget it, too lost in thought. Hannah would bang on the ceiling with a broom, her voice sharp through the floorboards. "Isaac, you'll starve up there." He'd mumble something, grab a crust, and climb back to his lair. The prism became his obsession. He'd sit for hours, tweaking the setup, blocking part of the beam with a card, letting only a sliver through, then watching the colors shift. He noticed something odd. The spectrum stretched longer than it should, wider than the beam itself. Why? He scribbled, crossed out, scribbled again. Maybe each color bent differently, red less, violet more. He tested it, measuring angles with a crude ruler, and the numbers whispered back, he was right. One afternoon, as thunder rumbled in the distance, he took it further. He grabbed a second prism, a spare he'd found in his satchel, and set it in the spectrum's path. If light was just one thing, split apart, could it be put back together? He angled the glass, held his breath, and watched. The colors converged, blending into a spot of white on the wall. He laughed, a short, sharp bark that echoed in the attic. White light wasn't the start, it was the end, a reunion of every hue. This was no theory from a dusty book. It was his, born from his hands and a piece of glass in a farmhouse no one cared about. He wrote it down. Light was a mix, a spectrum, and he'd cracked it open at 22. The attic became a battlefield of light and shadow. He'd pace, muttering to himself, his boots wearing grooves in the floor. The plague raged on outside, church bells tolling, death carts creaking, but he was untouchable, wrapped in his own universe. He'd sit by the window, shutters cracked, and let the sun pour in, splitting it again and again. He noticed how colors stayed pure, red stayed red, blue stayed blue, no matter how many prisms he used. This wasn't mixing paint. It was something deeper. He guessed, maybe light was made of tiny bits, particles darting through the air, each color a different kind. It was a wild leap against the wave ideas of men like Hooke, but it felt right. He scribbled it in the margin, light as corpuscles. He'd fight over that later, but for now, it was his secret. Weeks turned to months, and the prism wasn't enough. Winter 1665 crept in, frost rhyming the attic's edges, and Newton's mind leapt again. If light split into colors, could he use it to see farther, clearer? Back in Cambridge, he'd heard of telescopes, Galileo's tubes that peeked at Jupiter's moons, but they blurred, edges smudged with rainbows. He called it chromatic aberration, a flaw in the lenses bending light wrong. He sat one night, the candle flickering low, and sketched a fix. What if you didn't bend light with glass, but bounced it with a mirror? He drew a tube, a curved mirror at the bottom, light reflecting up to an eyepiece. No colors, no blur, just sharp, clean stars. Spring 1666 bloomed, the plague easing, and Newton stayed put, his attic a cave of wonders. He'd tinker with the prism by day, dream of mirrors by night. Cambridge called him back eventually, but the idea stuck. By 1668, at 25, he'd build it, a reflecting telescope, the first of its kind, a 6-inch tube of metal and glass that magnified the heavens without a hint of rainbow smear. He'd carry it under his arm, a wiry young man with a mop of hair, and show it off at Trinity, the stars snapping into focus like never before. Astronomers would gasp, the Royal Society would cheer, but that's jumping ahead. Back in Woolsthorpe, it was just a spark, a sketch on a page, born from a prism and a question. The story flows on, Newton's attic a glowing crucible as 1666 unfolds. His 23 now, the plague a fading echo, but he's still lost in light. He sits one morning, the sun spilling through the window, and tweaks his prism again. He blocks all but a thin beam, watches the spectrum stretch, red to violet, a perfect ribbon. He measures it, ruler trembling in his hand, and notes the angles. Red bends least, violet most. It's a law, he thinks, a rule light follows, like the apple's fall. He scribbles it down, pages piling up, a map of color no one's seen. He imagines raindrops doing this in the sky, splitting sunlight into rainbows, and grins. Nature's his teacher, and he's a quick student. He paces the attic, the floorboards groaning, and thinks of eyes, how they see, how they trick. He'd read Descartes, who'd cut open ox eyes to study lenses, but Newton goes further. One afternoon, he grabs a bodkin, a blunt needle, and stares at it, then at his reflection in a shard of glass. Could he test light inside himself? He slides the needle between his eye and the bone, pressing until colors swirl, reds, blues, a kaleidoscope of pain. He winces, pulls back, and writes it down. Pressure bends sight, light's alive in us too. It's mad, reckless, but it's him, pushing limits, even his own. Summer 1666 nears, and Newton's quirks deepen. He forgets meals, his mother's shouts a distant hum. "Isaac, you're a ghost," she'd call, but he'd wave her off, prism in hand. The attic's a mess, papers, prisms, sketches of mirrors, but it's his world. He sits one night, the stars sharp through the window, and links it all. The spectrum explains the telescope's blur. Lenses split light, mirrors don't. He refines his design, imagining a tube that could pierce the sky. He's not just playing with colors, he's building a bridge to the stars, all from a farmhouse attic at 23. Cambridge pulls him back in late 1666, the plague retreating, and he carries his secrets with him. The prism stays, the telescope grows. By 1668, he's a fellow at Trinity, 25 and wiry, hammering metal in a shed. He crafts that reflecting telescope, 6 inches long, a concave mirror inside, a marvel of clarity. He peers through it, Saturn's rings crisp, Jupiter's moons like pinpricks. He shows it to Isaac Barrow, his old mentor, who gapes. Word spreads, and by 1671, he sends it to the Royal Society in London. They test it, marvel at it, elect him a member in 1672. But that's not all smooth sailing. Robert Hooke, a loudmouth with a microscope, sneers. It's small, it's weak, he snaps, and Newton bristles, his temper flaring. Back in 1666, though, it's just the seed. He sits under the apple tree one evening, the prism glinting beside him, and reflects. Light's not what they thought, a pure beam, a wave. It's a chorus, a swarm of particles, and he's the first to hear it sing. He writes a paper in 1672, New Theory about Light and Colors, and sends it to the Society, the spectrum laid bare. Hooke attacks, claiming waves rule, and Newton fires back, his words sharp as knives. The feud's born, but in Woolsthorpe, it's pure, him, the prism, the light splitting clean. The real wonder's what it means. That telescope, born from his attic dreams, lets us see the cosmos, planets, galaxies, a universe unblurred. The spectrum unlocks rainbows, stars' secrets, even the glow of your screen right now. He stands in the garden, 1666 fading, the attic light burning behind him. His 23, a loner with a prism, and his rewritten light itself. The narrator chimes in, this is Newton's 20s, stay tuned, hit subscribe, because the genius isn't done shining. Chapter 4, The Laws of Motion, Foundations of Physics. The wind whispered through the orchard at Woolsthorpe Manor on a crisp autumn day in 1665, tugging at the leaves of the apple trees as Isaac Newton, 22 years old, stood beneath their sagging branches. The air carried the faint bite of coming winter, the fields beyond the stone farmhouse stretching golden and still under a sky streaked with clouds. Inside, the attic waited, his sanctuary of papers and prisms, ink-stained fingers, and flickering candles. But today, he lingered outside, his sharp eyes fixed on the world in motion. The plague had driven him here, shutting Cambridge's gates and turning England into a land of ghosts, but it had also given him this, a quiet stage to watch, to think, to unravel the rules that made everything tick. He'd already split light into rainbows, scribbled fluxions to chase curves, and felt the pull of an apple hint at a force beyond the garden. Now, as a leaf twirled down and a sheep ambled across the hill, he turned to something simpler, yet vast, why things move and why they stop. Newton kicked a pebble, watching it skitter across the grass, slowing until it settled in a patch of dirt. He'd seen it 1,000 times, stones rolling, apples falling, carts creaking to a halt, but today, it struck him differently. Back in Cambridge, he'd sat through lectures on Aristotle, the old Greek insisting things moved because they wanted to, seeking their natural place. Earth sank, fire rose, all driven by some inner urge. It was nonsense, Newton thought, kicking the pebble again. It didn't want anything, it rolled because he'd pushed it, stopped because the ground fought back. He'd read Galileo too, who'd dropped balls from towers and rolled them down ramps, proving motion wasn't magic. But Galileo had only peeked at the puzzle. Newton wanted the whole picture. He turned, his boots crunching the grass, and headed back to the attic, a question burning. What's the real law behind it all? Upstairs, the familiar chaos greeted him. Papers strewn like a storm had hit, a prism glinting in the corner, his notebook open to a page of half-formed ideas. The attic was dim, the shutters cracked just enough to let in a sliver of light, dust motes drifting like tiny worlds. He sat, the chair creaking under his slight frame, and grabbed his quill. Motion wasn't random, it had rules, patterns he could feel but not yet name. He thought of that pebble, it stayed still until he kicked it, then kept rolling until something, the grass, the dirt, slowed it down. He wrote it down, simple and sharp. A body at rest stays at rest, and a body in motion stays in motion, unless acted upon by a force. He stared at it, the words stark on the page. This was the first piece, a truth so obvious he wondered why no one had said it like that before. He leaned back, the attic silence wrapping around him, and pictured more. A cart in the village, pulled by a horse, it didn't budge until the beast heaved, then rolled steady once it started. A ball tossed in the air climbed high, then fell back, not because it wanted to, but because the earth tugged it down. That force again, the one from the apple, the moon. He scribbled a note, inertia. It was a word he'd tweak later, but it fit. Things like to keep doing what they were already doing, resisting change unless pushed or pulled. He grinned, a rare flicker of joy. This wasn't just about pebbles, it was everything, from a leaf in the wind to a planet in the sky. But what made them change? He stood, pacing the attic, his boots thumping a rhythm on the boards. The pebble rolled because he'd kicked it. Force, effort, a shove. He thought of the horse and cart again. The harder it pulled, the faster the cart moved. He'd seen boys in Grantham kick balls, little taps sent them trickling, big boots launched them far. There was a rule there too. He sat again, quill flying, and wrote, "The change in motion is proportional to the force applied, and happens in the direction of that force." He paused, chewing the end of his quill. It needed math, his fluxions could help, but for now, he kept it plain. Force equaled something, motion changing, mass resisting. He'd refine it later, but the seed was planted. He tested it in his head. A heavy stone took more effort to kick than a light one. Mass mattered. He imagined a cannonball, fired hard, soaring farther than a pebble tossed by hand. Force and mass danced together, deciding how fast, how far. He scribbled a sketch, a line for the kick, an arc for the roll, and saw it fit. This was the second law, rough but alive, a bridge between effort and outcome. He leaned out the window, the breeze cool on his face, and watched a bird flap against the wind. More force, more speed, it held there too. His heart thudded. This wasn't just Woolsthorpe, it was the universe. The attic grew darker as evening fell, and Newton lit a candle, the flame casting shadows that danced like his thoughts. 2 laws down, but something nagged at him. He thought of the bird again, it pushed the air, and the air pushed back, keeping it aloft. He'd seen it elsewhere, oars in a stream, a shove against a wall. He pushed his hand against the table, felt it press back. Nothing moved, but the force was there, equal, opposite. He wrote it down, quick and sure, for every action, there's an equal and opposite reaction. He stared at it, the third piece clicking into place. This was the balance, push and pull, give and take, a cosmic handshake. He stood again, pacing faster, the attic a cage for his racing mind. 3 laws, born from a pebble, a bird, a table, simple, yet vast. He imagined them everywhere. A horse pulling a plough, the ground pushing back, a ball falling, the Earth pulling while the ball pulled too, tiny but real, the Moon orbiting, tugged by Earth, tugging in return. He grabbed his notebook, flipping to his Apple sketches. That force, gravity, he'd call it later, fit here too. The first law kept the Moon moving, the second shaped its curve, the third tied it to Earth. He laughed, a sharp bark that echoed off the walls. This was it, the skeleton of motion, stripped bare and laid out at 23. The story flows on, Newton's attic a glowing forge as autumn deepens into winter 1665. His lost in his laws, the candle burning low, wax pooling on the table. He tests them again, his mind a whirlwind. He kicks a heavier stone outside, feels the effort, watches it roll shorter than the pebble. Mass resists, the second law holds. He tosses an apple up, catches it as it falls, the first law in stillness, the second in its drop, the third in his hands push against its weight. He scribbles, pages piling up, a map of motion no one's drawn. The plague rages beyond Woolsthorpe, but his untouchable, a king in his attic kingdom. Winter bites, frost rhyming the windows, and Newton's quirks flare. He forgets meals, his mother's shouts, "Isaac, come down." A distant hum. He waves her off, bread crumbling in his hand, and climbs back up. The attic's a mess, papers, quills, sketches of carts and birds, but it's his world. He sits one night, the stars sharp outside, and links his laws to the sky. The moon's orbit. Why doesn't it fly off? The first law says it should, straight and free, but the second bends it, gravity's force pulling just right. The third seals it, Earth pulls Moon, Moon pulls Earth, a dance of equals. He calculates, rough numbers from his apple guesses, and it fits. His breath fogs the glass as he grins. Spring 1666 tiptoes in, the plague easing, and Newton stays put, refining his thoughts. He paces the orchard, watching sheep plod, their hooves pressing the ground pressing back. The third law's everywhere, every step, every shove. He imagines a cannon firing, the ball blasting out, the cannon jolting back, action, reaction, perfect. He sits under the apple tree, notebook open, and writes it cleaner. A body continues in its state of rest or uniform motion unless compelled by a force. The acceleration is proportional to the force and inversely to the mass. Every action has an equal opposite reaction. It's raw, unpolished, but it sings. Cambridge calls him back in late 1666, the world waking up, but the laws stay with him. He's 23, a nobody to most, but he's holding the universe's blueprint. Years pass, and by 1687, at 44, he'll polish them into the Principia, 3 laws that shake the world. But back in Woolsthorpe, it's just him, the attic, the orchard, a 20-something dreaming big. He tests them in his head, a ship sailing, wind pushing sails, water pushing back, a planet spinning, gravity pulling, inertia fighting. They hold, every time, a skeleton key to motion itself. Summer 1666 nears, and Newton knows his solitude's ending. He sits one evening, the sky bruising purple, and reflects. These laws aren't just rules, they're a revolution. He imagines bridges standing, cannons firing, ships crossing oceans, all bowing to his attic scribbles. He stands, the grass damp under his boots, and tosses an apple high. It arcs, falls, lands with a thud, the first law in its climb, the second in its drop, the third in the earth's reply. He grins, rare and bright. This is his gift, forged in a year of death while he hid away at 23. The real magic's what comes next. Those laws lift us to the moon, power planes, spin turbines. Your car, your bike, your every step, they're Newton's echo. He walks back to the house, the attic light glowing, a beacon in a world rebuilding. He's not done, he'll fight Hooke over them, refine them with fluxions, publish them to awe, but the seeds here, planted in Woolsthorpe silence. The narrator chimes in, this is Newton's 20s, 3 laws that move us still. Hit subscribe, because the genius keeps rolling. Chapter 5. Gravity, the force that binds. The orchard at Woolsthorpe Manor shimmered under a late summer sun in 1665, the apple trees heavy with fruit, their branches bowing as if in quiet surrender. Isaac Newton, 22 years old, stood beneath one, his boots sinking into the soft grass, the air thick with the scent of ripeness and earth. Beyond the stone walls of the farmhouse, England lay in the grip of the plague, villages silent, church bells tolling a mournful tune. But here, in this pocket of stillness, Newton's mind was anything but quiet. The attic upstairs held his prisms and papers, his fluxions and laws of motion. But today, he lingered outside, his sharp eyes tracing the arc of a falling apple. It wasn't the first he'd seen drop. Weeks ago, maybe months, one had thudded to the ground and sparked a question that wouldn't let go. Why down? Why always down? And could that same pull reach beyond the tree, beyond the sky, to the moon itself? Now, as another apple broke free and landed with a soft thump, he felt it again, a whisper of something vast, a force that tied everything together. He bent down, picked up the apple, and rolled it in his hand, its weight a small, solid truth. The plague had driven him here, shutting Cambridge's doors and turning the world into a shadow of itself, but it had also handed him this, time to watch, to wonder, to chase the threads of the universe. He'd already split light into colors, crafted fluxions to measure change, and scribbled rules for motion that felt like the skeleton of reality. But this pull, was different. It wasn't just about apples or pebbles, it was about the moon hanging pale in the daytime sky, the stars pricking the night, the earth itself spinning beneath his feet. He tossed the apple up, watched it climb, slow, and fall back into his palm. Something tugged it down, something invisible, relentless. He'd felt it before, named it in his motion laws, but now it loomed larger, a force that didn't just rule the orchard, but everything. He turned, his boots crunching the grass, and climbed the narrow stairs to the attic, the familiar creak of the boards welcoming him back. The room was a storm of papers, sketches of curves, prisms glinting in the corner, a candle stub drowning in wax. He sat at his table, the wood scarred from months of restless thought, and opened his notebook to a page he'd started weeks ago. A circle for the earth, a dot for the apple, a line for the fall. He'd guessed then that the pull was a force, a shove from the earth itself, but now he wanted more. He looked out the window, the moon a faint crescent against the blue, and let his mind stretch. If the earth pulled the apple, could it pull the moon too? And if it did, how? He grabbed his quill, the ink smudging under his fingers, and started writing. The apple fell fast, a few feet in a second. He'd timed it roughly with his pulse. The moon, though, was far, hundreds of thousands of miles, a distance he'd gleaned from books by Kepler and Galileo. It didn't plummet, it circled, a slow, steady dance that took 27 days. He scribbled numbers, his hand trembling with excitement. The apple's fall was quick, the moon's fall a gentle curve, same force, different scales. He remembered his fluxions, the way they tracked motion's bend. Could they bridge this gap? He sketched the moon's path, a circle for now, and imagined it falling toward Earth, not crashing, but turning aside, caught in a balance. His heart thudded. This wasn't two forces, it was one, stretching from the garden to the sky. He leaned back, the chair groaning, and rubbed his eyes. The attic was warm, the air heavy with the day's heat, but he barely noticed. He thought of light fading with distance, stand farther from a candle, and it dims. Maybe this force worked the same way. He'd guessed it before, with the apple and the moon. What if it weakened as the distance grew, not just a little, but by the square? Double the distance, a quarter the pull. Triple it, a ninth. He scribbled again, pulling rough figures from memory. Earth's size, the moon's orbit, the apple's drop. He calculated how fast the moon fell to stay in its path, how weak the force would be that far out. The numbers were crude, his data shaky, but they lined up close enough to make him gasp. This was it, a law, a thread tying apple to moon, earth to everything. He stood, pacing the attic, his boots thumping a rhythm on the floor. The plague was a distant hum, death carts creaking, bells tolling, but he was lost in this. He imagined the stars, the planets Kepler had mapped, all pulled by their suns. He'd read of Jupiter's moons, spinning tight and fast, same force, closer grip. He sat again, quill flying, and wrote, "Every body attracts every other body with a force proportional to their masses and inversely proportional to the square of the distance between them." It was rough, unpolished, but it sang, a universal law, born in a farmhouse attic at 22. The story flows on, Newton's attic a glowing crucible as autumn 1665 deepens. He's obsessed now, the apples fall a spark that's lit a fire. He sits one night, the candle flickering low, and tests his guess. He sketches the earth, the moon, a line of force stretching thin. He pulls his motion laws into it. The first kept the moon moving, the second bent its path, the third paired Earth's pull with the moon's faint tug back. He calculates again, fluxions tracing the curve, and it holds. The moon falls just enough to circle, not crash, gravity's balance, perfect and wild. He laughs, a sharp sound in the silence, and scribbles more. Winter creeps in, frost rhyming the windows, and Newton's quirks flare. He forgets meals, his mother's shouts, "Isaac, you'll waste away." A distant echo. He waves her off, an apple in hand, and climbs back up. The attic's a mess, papers, sketches, numbers spilling everywhere, but it's his universe. He paces, muttering, and thinks of the sun. If Earth pulls the moon, does the sun pull Earth? He imagines planets dancing, their ellipses Kepler's gift, all tugged by this force. He scribbles a solar system, lines of gravity threading through, and grins. This isn't just Woolsthorpe, it's everything, everywhere. Spring 1666 blooms, the plague easing, and Newton stays put, refining his vision. He sits under the apple tree, notebook open, and watches a leaf drift down, slow, steady, pulled like the apple. He calculates its fall, rough but real, and links it to the moon. Same law, different scale, mass mattered, distance ruled. He imagines a cannonball fired high. If it went fast enough, could it circle Earth like the moon? He sketches it, a wild arc, and sees the truth. Gravity's not just a pull down, it's a curve, a dance. He writes it cleaner, a universal force, binding all masses, fading with the square of distance. It's raw, but it's alive. Cambridge calls him back in late 1666, the world stirring, but gravity stays with him. He's 23, a loner with a secret, and he tucks it away. Years pass, and by 1687, at 44, he'll polish it into the Principia, a law that shakes the cosmos. But back in Woolsthorpe, it's just him, the orchard, the attic, a 20-something dreaming vast. He tests it in his head, tides rising, pulled by the moon, comets soaring, bent by the sun. They fit, every time, a key to the heavens. Summer 1666 nears, and Newton knows his solitude's fading. He sits one evening, the sky a bruise of purple, and reflects. This force isn't just a rule, it's a bond. He imagines ships sailing, their weight pressing the sea pressing back, all gravity's echo. He stands, tosses an apple high, watches it arc and thud, the pull his named, the law his caught. He grins, rare and bright. This is his gift, forged in a year of death while he hid at 23. The real wonder's what it unlocks. That law lifts us to space, tracks planets, predicts comets. Halley's would prove it, streaking back in 1758 because Newton said it would. He walks back to the house, the attic light glowing, a beacon in a world waking up. He's not done, he'll fight Hooke over it, refine it with math, publish it to all, but the seed's here, planted in Woolsthorpe silence. The narrator chimes in, this is Newton's 20s, gravity binds us still. Hit subscribe, because the genius keeps pulling. Chapter 6. Academic Ascendancy. The cobblestone paths of Cambridge glistened under a weak spring sun in 1667, the air sharp with the scent of damp earth and budding leaves. Isaac Newton, 24 years old, stepped through the gates of Trinity College, his boots scuffing the stones, a battered satchel slung over his shoulder. The plague had finally loosened its grip on England, the death carts fading into memory, and the university had called its scattered students back. Woolsthorpe was behind him now, its quiet orchard, its attic thick with papers, its secrets of light, motion, and gravity tucked into his mind like treasures in a chest. He'd spent nearly 2 years there, a 20-something loner wrestling with the universe, and he'd emerged with ideas that burned too bright to keep hidden. Cambridge loomed ahead, its stone towers and bustling halls a stark contrast to the solitude he'd known, and Newton felt a flicker of something. Nervousness, maybe, or the weight of what he carried. This wasn't just a return. It was a beginning. The college buzzed with life as he crossed the great court, students chattering, their voices a jarring hum after months of silence. He'd been a sizer here before, emptying chamber pots, serving richer boys to pay his way, but that felt like another life. Woolsthorpe had changed him, sharpened him, and he wasn't the awkward 18-year-old who'd arrived in 1661. He climbed the stairs to his old room, a narrow cell with a single window, and dropped his satchel on the bed. The walls were bare, the air musty, but it'd do. He unpacked his treasures, notebooks crammed with fluxions, sketches of prisms and falling apples, equations that danced with motion and force. He ran a hand over them, the ink smudged from restless nights, and grinned, a rare, fleeting curve of his lips. This was his arsenal, forged in isolation, and Cambridge was about to feel its weight. Days settled into a rhythm, but not the one he'd known before. He was a fellow now, elected in October 1667, his brilliance too obvious to ignore. No more scrubbing floors or fetching ale. Trinity had seen something in him, maybe sparked by whispers of his plague year work. He'd earned his bachelor's degree just before the shutdown, a quiet nod to his promise, but now he was free to study, to think, to chase the threads he'd spun at home. The library became his haunt, its shelves groaning with books, Galileo's experiments, Kepler's orbits, Descartes' geometry. He'd sit for hours, hunched over a table, his dark hair falling into his eyes, scribbling notes that spilled beyond the margins. Students passed him by, some nodding, most ignoring the wiry figure lost in his own world. He didn't care. Friends were a distraction. Ideas were his company. Cambridge wasn't all quiet study, though. The air crackled with the scientific revolution, a storm breaking over centuries of dogma. Professors debated Copernicus, who'd shoved the sun to the center of the cosmos, and Boyle, who'd bottled air to prove it had weight. Newton soaked it in, his mind a sponge, but he kept his own counsel. He'd split light into colors, tied apples to moons, but he didn't shout it from the rooftops. Not yet. He'd wander the grounds, hands clasped behind his back, muttering to himself as he pieced it together. One afternoon, he paused by the chapel, watching a bird flap against the wind. Motion's laws at play, gravity pulling, wings pushing back. He grinned again, sharper this time. Woolsthorpe had been his forge. Cambridge would be his anvil. His rise was swift, almost dizzying. In 1668, at 25, he was grinding glass in a shed behind Trinity, his hands black with soot, crafting that reflecting telescope he'd dreamed up at home. The prism had shown him light's flaws, lenses blurred, colors smudged, but a mirror could fix it. He hammered metal, polished curves, and built a 6-inch tube that snapped the stars into focus. He'd carry it under his arm, a wiry figure in a worn coat, and show it to anyone who'd look. Isaac Barrow, his old mentor and the Lucasian professor of mathematics, peered through it one evening, Saturn's rings crisp as a blade. "Good God, Newton," Barrow muttered, his voice thick with awe. Word spread, students gawked, fellows whispered, and Newton felt a flicker of pride, though he'd never admit it. Then came 1669, a year that turned the flicker into a flame. Barrow was tired, his lectures dense, his eyes on divinity more than math, and he saw Newton's fire. One October day, he called him to his rooms, the air heavy with pipe smoke and old books. "I'm stepping down," Barrow said, his voice gravelly. "The Lucasian chair's yours if you'll take it." Newton froze, his sharp eyes narrowing. He was 26, barely a decade past his Sizer days, and now this, a professorship, one of Cambridge's highest honors, handed to him like a crown. He nodded, words failing him, and Barrow clapped his shoulder. "You'll do wonders, boy," he said, and Newton felt the weight settle. October 29, 1669, he took the chair, a 20-something genius thrust into the spotlight. The story flows on, Newton's new role a whirlwind as 1669 fades into 1670. He's 27 now, the Lucasian professor, his name whispered in halls he once scrubbed. He moves to better rooms, still sparse, but with a desk and a window overlooking the court. He's meant to lecture, to teach, and he tries. He stands in a dim hall, his voice low and clipped, scribbling fluxions and optics on a board. But the students, spoiled sons of gentry, more keen on ale than math, yawn or skip out. One day, he lectures to an empty room, his chalk squeaking, and shrugs. "Their loss," he mutters, and keeps writing. He's not there for them. He's there for the work. His quirks bloom in the spotlight. He forgets meals, his landlady banging on his door with bread and broth. "Mr. Newton, you'll fade away." He waves her off, lost in thought, his shirt stained with ink. He paces at night, boots thumping, neighbors grumbling through the walls. He builds contraptions, windmills, sundials, scattered across his rooms like a child's toys grown wild. One morning, he cuts a hole in his door, rigs a flap for his cat, then another for her kittens, grinning at the logic. Students snicker, call him odd, but he doesn't care. The world's a puzzle, and he's solving it, one piece at a time. He mentors a few, though, bright sparks who see past his prickly shell. Humphrey Babington, a fellow, lingers after a lecture, asking about light. Newton shows him the prism, splits a beam, and watches the man's eyes widen. Another, a young scholar named John Wickens, stumbles into his rooms one day, fleeing a loud roommate. "Stay," Newton says, and Wickens does, becoming his scribe, his shadow, copying pages of fluxions and laws. They talk late, candles burning low, and Newton softens, just a touch, around someone who listens. Cambridge isn't all peace, though. Rivalries simmer, old guards scoff at his youth, his ideas. He clashes with a mathematician over tangents, his temper flaring, words sharp as knives. "Fools," he mutters, stalking off. He keeps his gravity close, his telescope a quiet triumph, but his restless. One night, he stands by the river Cam, the water glinting under the moon, and feels it, the pull he'd guessed at Woolsthorpe, binding earth to sky. He's not ready to share it, not fully, but it's there, growing. By 1671, at 28, his telescope reaches London, the Royal Society marvelling at its clarity. They elect him in 1672, a nod to his 20s brilliance, but that's ahead. Back in 1669, he's still finding his footing, a professor who'd rather scribble than speak. He sits one evening, the fire crackling, and flips through his notes. Light, motion, gravity, a universe unfolding. He's 26, a loner in a scholar's gown, and he's rewriting the world. The real wonder's what's coming, those laws, that force, a Principia to shake the ages, all rooted in his 20s fire. The narrator chimes in, "This is Newton ascending, hit subscribe, because the genius is just warming up." Chapter 7. The Royal Society, Recognition and Rivalry. The frost crunched under Isaac Newton's boots as he stepped into the bustling streets of London in January 1672, the air sharp with coal smoke and the tang of the Thames. He was 29 now, a wiry figure in a plain coat, his dark hair tucked under a hat, clutching a wooden box that held his pride, a 6-inch reflecting telescope, its metal glinting faintly in the weak winter light. Cambridge lay behind him, its quiet halls, its empty lectures, his Lucasian chair a steady perch, but today he'd been summoned to a grander stage. The Royal Society, England's beating heart of science, housed in Gresham College's creaking rooms. Woolsthorpe's attic felt a lifetime ago, those plague years of 1665 to 1666 when he'd split light, chased motion, and felt gravity's pull at 22 to 23. Now, at the edge of his 20s, he was here to show the world what he'd wrought, a nervous thrill humming in his chest as he pushed through the city's chaos toward fame or a fight. The society's meeting room buzzed with voices as he slipped inside, the walls lined with books and the air thick with pipe smoke. Men in wigs and velvet, scholars, nobles, inventors, leaned over tables strewn with gadgets and papers, their chatter a mix of Latin and English, pomp and curiosity. Newton's telescope had reached them months ago, sent from Cambridge in 1671 after whispers of its clarity spread. He'd built it in 1668, a 25-year-old grinding mirrors in a Trinity shed, dreaming of stars unblurred by rainbow smudges. Now, they'd called him to present it, to prove its worth. He set the box down, his hand steady despite the knot in his gut, and unpacked it. A sleek tube, a concave mirror nestled inside, a lens at the eyepiece. The room quieted as he stepped forward, his voice low and clipped, not made for crowds. "Gentlemen," he began, "this reflects light, not refracts it. No colors, no blur, just truth." He aimed it at a window, the grey London sky a poor substitute for stars, but enough. One by one, they peered through, Henry Oldenburg, the Society's secretary, squinting. John Wallace, the mathematician, nodding slow. Christopher Wren, the architect, letting out a soft remarkable. Saturn's rings snapped into view, crisp as a blade, no chromatic haze to muddy them. Gasps rippled through the room, then murmurs of awe. "Galileo's lenses couldn't do this," someone muttered. Newton stood back, his sharp eyes flicking over them, a flicker of pride tugging at his lips. He'd fixed light's flaw, turned his Woolsthorpe prism dreams into metal and glass, and they saw it. On January 11, 1672, they voted him in, a Fellow of the Royal Society at 29, his 20s crowned with recognition. But fame wasn't all applause. A shadow loomed across the room, Robert Hooke, a wiry man with a crooked back and a voice like a whip, the Society's curator of experiments. Hooke had peered through the telescope too, his lips pursed, his eyes narrow. He'd built microscopes, stared at fleas and cork, and fancied himself the king of optics. Newton's tube was small, 6 inches to Hooke's grander lenses, and Hooke didn't hide his scorn. A toy, he'd sniffed later, scribbling a critique that stung like a slap. It magnifies little, resolves less. Newton bristled, his temper, a beast he kept chained, stirring. He'd poured years into this, from attic sketches to Cambridge sheds, and now this loudmouth dared dismiss it. He fired back a letter, his words sharp as glass. It sees farther than your lenses ever will. The room felt it, the first spark of a rivalry that had blazed for decades. Weeks later, Newton stoked the fire higher. He'd sent a paper with the telescope, a new theory about light and colors, his Woolsthorpe prism work laid bare. He stood again, February 1672, the Society packed, his voice steady despite the crowd. Light isn't one, he said, it's many, red, orange, yellow, split by a prism, each bending its own way. He'd proved it at 22, sunlight spilling rainbows across his attic wall, and now he showed them, a prism in hand, a beam slicing through, colors blooming on a screen. The room erupted, some cheered, some scribbled, but Hooke leapt up, his face red. Nonsense, he barked. Light's a wave, not particles. Your corpuscles are fantasy. Newton's jaw tightened, his hands curling into fists. Hooke had read Descartes, played with ripples, but Newton had seen it. Colors pure, unmixing, a truth Hooke couldn't touch. The clash echoed beyond the room. Letters flew, Hooke's taunts, Newton's icy retorts. You claim what you haven't tested, Newton wrote, his quill slashing the page. Hooke fired back, your telescope's a trifle, your theory a jest. Newton paced his Cambridge rooms, the fire crackling, his temper boiling over. He'd given them light's secret, his 20s gift, and this man, this hunchbacked braggart, dared call it lies? He nearly quit, drafting a resignation, but Oldenburg begged him to stay. Your work's too grand, he wrote, and Newton relented, though the wound festered. Hooke wasn't just a rival, he was a thorn, a shadow on his rise. The story flows on, Newton's Royal Society debut a storm of glory and grit through 1672. His 29, teetering on 30, his 20s a blaze of brilliance now tested by fire. The telescope sits in London, a quiet marvel, but the optics paper steals the show. Scholars dissect it, some hail him as a new Galileo, others side with Hooke, whispering of waves. Newton retreats to Cambridge, his room's a fortress, papers piling up as he refines his case. He scribbles late, candles burning to stubs, his landlady banging, Mr. Newton, sleep. He waves her off, lost in light's dance, his Woolsthorpe rainbows his shield. Hooke's barbs sting, but the Society's nod holds, his fellowship's real, his name rising. Spring 1672 blooms, and Newton's quirks flare under pressure. He forgets meals, his coat stained with ink, his cat flap creaking as kittens dart through. He paces the Trinity court, muttering, students staring at the odd professor who'd rather fight on paper than in person. He writes Oldenburg, calm but cutting, Mr. Hooke mistakes my meaning, experiments, not words, prove truth. The Society tests his prism trick, colors split, white reforms, and nods spread. Wren writes, a revelation, and Newton feels it, his 20s work, born in an attic, now echoes in London's halls. Hooke doesn't quit. He struts at meetings, waving his own papers, claiming light bends like water, not darts like Newton's corpuscles. Newton fires back, his letters sharp, Your waves explain nothing, my prism shows all. The feud's a spectacle, scholars pick sides, bets fly in coffee houses. Newton hates it, his solitude pierced, but he won't yield. He'd seen the spectrum at 22, felt gravity's pull at 23, and this, his light, was no guess. He sits one night, the cam glinting outside, and sketches his telescope again, dreaming of stars Hooke can't blur. The Society keeps it, a trophy of his youth, and he clings to that. Summer 1672 fades, and Newton's recognition solidifies. His optics papers printed, his name inked in journals, a 20-something genius the world can't ignore. Hooke sulks, plotting, but the telescope stands, Jupiter's moons clear, Saturn's rings sharp. Newton's temper cools, though the scar stays. He writes less, hoards his gravity and laws, saving them for later. One evening, he stands by his window, the sky bruising purple, and reflects. Woolsthorpe gave him the spark, Cambridge the forge, the Society the flame. His 29, a loner with a fellowship, and his shaken science's core. The real wonder's the ripple. That telescope births astronomy's future, stars mapped, planets tracked, all from his 20s dream. The optics fight seeds centuries of debate, light's nature, wave or particle, a question he'd frame. He walks back to his desk, the fire low, and flips his notebook. Fluxions, motion, gravity waiting. Hooke's a thorn, but the Society's his stage, his 20s a foundation for a Principia to come. The narrator chimes in, this is Newton's rise, rivalry and all. Hit subscribe, because the genius isn't done fighting. Chapter 8. The Man Behind the Genius. The attic of Woolsthorpe Manor creaked under a late summer storm in 1665, rain lashing the roof as Isaac Newton, 22 years old, sat hunched over a scarred wooden table. Lightning flashed through the shutters, casting jagged shadows across a chaos of papers, scribbled fluxions, prism sketches, applefall equations, a map of a mind that never stopped. The air was thick with the scent of damp wood and melted wax, a candle flickering low, its light barely touching the corners of the cramped space. Outside, England groaned under the plague's weight, villages silent, death carts rolling. But here, in this attic, Newton was a world unto himself. He'd already split light into rainbows, chased motion's laws, and felt gravity's pull, but who was this young man behind the genius? Not a hero in a cape, not a sage with a beard, just a wiry, sharp-eyed loner, his dark hair tangled, his hands stained with ink, driven by something deeper than fame or gold. He leaned back, the chair groaning under his slight frame, and rubbed his eyes, the storm a distant roar. Newton wasn't like the boys he'd known in Grantham, rough, loud, scrapping in the dirt. He'd been the odd one, building sundials while they wrestled, sketching gears while they chased girls. Born on Christmas Day 1642, or January 4, 1643, by the new calendar, he'd come into the world small and frail, his father dead, his mother leaving him at 3 to a grandmother's cold care. That solitude stuck, a scar he carried into his 20s. He didn't need people. Books were better, ideas truer. At Woolsthorpe, with the plague shutting the world away, he thrived. He'd pace the orchard, muttering to himself, or sit for hours, quill scratching, forgetting the bread his mother left by the stairs. "Isaac, you'll starve," she'd shout, banging a pot, but he'd wave her off, lost in a puzzle only he could see. His mind was a furnace, burning hot and relentless. He'd sit in the attic till dawn, candle stubs piling up, his shirt crumpled from days unchanged. Sleep was a thief. He'd nap in fits, slumped over the table, waking with ink on his cheek and a new equation in his head. One night, he stared at the prism, its colors glinting in the dark, and didn't move for hours, tracing light's path in his mind. Another, he scribbled fluxions till his hand cramped, breaking motion into pieces no one else could grasp. His mother called him possessed. His half-siblings steered clear. He didn't care. This wasn't work, it was breath, life, the only thing that made sense in a world of chaos. But it wasn't just science that gripped him. Downstairs, in a corner of the farmhouse, he'd rigged a makeshift lab. Jars of mercury, lumps of lead, a furnace glowing red. Alchemy was his shadow passion, a secret he'd chased through his 20s and beyond. He'd read Paracelsus, the mystic who'd spun gold from base metals, and believed there was truth in the old art. He'd heat sulfur, watch it bubble, scribbling notes on transformations. Could matter shift? Could life's essence be distilled? It wasn't mad to him, it was another puzzle, a mirror to his physics. At 23, as the plague raged, he'd sit by the fire, stirring a pot of molten metal, dreaming of the philosopher's stone. Not for wealth, but for knowledge, a key to nature's core. Theology, too, pulled him deep. He'd haul a Bible upstairs, its pages worn, and pore over it like a code. He didn't buy the Trinity, God was one, he'd argue to himself, flipping through Revelation, Daniel, mapping end times with the same zeal he gave gravity. He'd scribble timelines, dates, 1666, the plague year, felt biblical, a sign. He kept it quiet, heresy could ruin him, but it shaped him, a thread of faith woven into his science. One evening, as thunder rolled, he sat with the Bible open, quill in hand, linking prophecy to orbits, God's hand to the moon's pull. To him, it wasn't separate. The universe was one, divine and mechanical, and he'd crack it all. Cambridge called him back in 1667, 24 now, and he carried that fire with him. Trinity's halls were louder, students chattering, but he stayed apart. He'd walk the great court, hands clasped behind his back, his sharp eyes fixed on nothing, lost in thought. He'd earned a fellowship, then the Lucasian chair in 1669 at 26, but teaching didn't suit him. He'd lecture on fluxions, his voice a monotone, chalk squeaking, while boys yawned or slipped out. Their loss, he'd mutter, and keep going, empty room or not. He mentored a few, Wickens, Babington, but friends were rare. He'd rather tinker alone, a sundial on his sill, a cat flap in his door, grinning at its logic while students snickered. The story flows on, Newton's 20s a tapestry of brilliance and oddity as 1669 turns to 1670. His 27, the Lucasian professor, his name rising, but he's still the attic dreamer. His rooms at Trinity are sparse, books, papers, a furnace glowing in the corner. He'd sit late, stirring mercury, the fumes sharp, chasing alchemy's ghosts. There's a law here, he'd mutter, linking it to gravity's pull, light's dance. Students saw the smoke, whispered of witchcraft, but he ignored them. He'd flip to the Bible, tracing numbers. 666, the beast, a puzzle like his series. His mind wove it all, science, faith, the occult, into one grand knot. His temper flared too, a beast he couldn't tame. A scholar questioned his optics in 1671, and Newton snapped, his voice cutting, "Test it yourself, fool." He'd storm off, pacing the Cambs banks, the water glinting under the moon. Hooke's shadow loomed, 1672 would bring their clash, but even now, he bristled at doubt. He'd given the Royal Society his telescope, his light theory, and they'd cheered, but criticism stung. He'd retreat, papers his shield, and scribble fiercer, fluxions sharper, gravity tighter. "They'll see," he'd growl, alone with his fire. His body took the toll. He'd forget meals, his landlady banging, "Mr. Newton, eat." And he'd grab a crust, distracted. He'd pace till dawn, boots thumping, neighbors pounding the walls. One night, he stared at the stars, the telescope's echo in his mind, and didn't sleep. Saturn's rings, gravity's curve, a universe he owned. He'd collapse at noon, wake at dusk, and start again. His cat roamed free, kittens tumbling through his flap, a rare laugh breaking his gloom. Clever beasts, he'd say, tossing them scraps, a flicker of warmth in his cold world. By 1672, at 29, the Royal Society crowned his 20s. Telescope fame, optics fights, but Woolsthorpe's mark stayed. He'd stand in his rooms, the fire low, and flip his notebooks. Prism colors, motion laws, gravity's whisper, all born in that attic at 22. Alchemy simmered, theology hummed, science soared, and he was their weaver. He wasn't easy, prickly, obsessive, a loner who'd rather argue with God than men, but that's what made him. The real wonder's the man, a 20-something misfit who cracked the cosmos, his quirks the fuel, his solitude the flame. The narrator chimes in, "This is Newton, raw and real. Hit subscribe, because the genius lives on." Chapter 9. Prelude to the Principia. The fire crackled in Isaac Newton's Cambridge rooms on a chill autumn night in 1672, the air heavy with the scent of burning logs and old books. He was 29, teetering on the edge of his 20s, his wiry frame hunched over a desk strewn with papers, prism sketches, fluxion tables, notes on gravity's pull from Woolsthorpe's plague years. The Royal Society had just crowned him a fellow, his reflecting telescope a marvel, his optics paper a lightning rod, but the glow of recognition flickered against the shadow of Robert Hooke's sneers. Newton's sharp eyes glinted in the firelight, his dark hair tangled from restless hands, as he flipped through a notebook that held the seeds of something vast. Woolsthorpe's attic, 7 years past, had birthed his genius. Light split, motion ruled, and apples fall tied to the moon. But here, in the quiet of Trinity College, those seeds were growing, twisting into roots that'd soon shake the world. This wasn't the end of his 20s fire, it was the start of something bigger, a prelude to a book that'd echo through centuries. He leaned back, the chair creaking under him, and rubbed his temples. The Royal Society clash had left a scar, Hooke's taunts about waves, his dismissal of the telescope as a toy. Newton had fired back, his quill slashing letters sharp as knives, but he'd pulled away after, hoarding his deeper thoughts. Fluxions, motion's laws, gravity's whisper, they were his, not ready for the world's noise. He'd lecture as Lucasian professor, his voice a monotone drone to half-empty rooms, students yawning over calculus they couldn't grasp. Their loss, he'd mutter, chalk dust on his coat, and retreat to his desk. Cambridge was a cage sometimes, its walls pressing in, but it was also a forge, hammering his ideas into shape. He'd pace the great court, hands clasped behind his back, the moon a pale ghost overhead, and feel it again, the pull he'd guessed at 22, binding apple to earth, earth to sky. One evening, as frost rimed the windows, he sat with his Woolsthorpe notes, the apples fall a spark that wouldn't fade. He'd scribbled then about a force fading with distance squared, double the gap, a quarter the pull, and tested it rough with the moon. The numbers had been close, not perfect, his data too crude. Now, at 29, he dug deeper. He pulled books, Kepler's orbits, Galileo's drops, and recalculated, his quill scratching a rhythm. The Earth's size, the moon's path, the apple's drop, he refined them, fluxions tracing the curve. It fit closer, the force universal, stretching beyond the orchard. He wrote it cleaner. Every body attracts every other, proportional to mass, inverse to distance squared. He stared at it, heart thudding. This wasn't just a guess, it was a law, a thread weaving the cosmos. But he kept it quiet. Hooke's shadow loomed, claiming gravity as his own, muttering about forces, and Newton wouldn't share yet. He'd pace his rooms, boots thumping, muttering, "Let him prove it first." He turned to other fires. Alchemy simmered in a corner furnace, mercury glowing, theology in a worn Bible, its pages thick with notes. He'd stir metals, chase the philosopher's stone, then flip to Revelation, mapping God's plan with the same zeal he gave orbits. Students whispered of smoke, of madness, but he grinned, a rare flash, linking it all. Gravity wasn't just physics, it was divine, a piece of the grand design he'd unravel alone. Years ticked by, his 20s bleeding into his 30s. By 1679, at 36, he was a fixture at Trinity. Prickly, brilliant, a loner with a cat flap and a telescope. Hooke wrote that year, a letter dripping with false charm, asking about orbits. Newton bristled, his temper flaring, but replied coolly, "A body falls in a curve, test it yourself." Hooke crowed, claiming the inverse square, and Newton smirked, knowing he'd held it since 23. He sketched a cannonball fired high, circling Earth if fast enough, a seed of orbits he'd planted in Woolsthorpe. Hooke fumbled, and Newton let him, his silence a weapon. Then came 1684, a spark that lit the fuse. Edmund Halley, a young astronomer with a mop of curls, knocked on his door one August day, the air thick with summer heat. "What path does a planet take under an inverse square force?" Halley asked, eyes bright. Newton paused, his sharp gaze flicking over him. "An ellipse," he said, flat and sure. Halley gaped. "How do you know?" Newton shrugged, digging out a paper from 1679. "Fluxions, laws, gravity woven tight. I've calculated it." Halley pressed, "Publish it, Hooke's claiming it, Wren's betting on it." Newton's jaw tightened, but something shifted. His 20s work, hoarded for years, clamored to breathe. The story flows on, Newton's room's a crucible as 1684 unfolds. He's 41 now, his 20s a distant blaze, but their embers glow fierce. Halley's visit rattles him. Hooke's shadow, the world's eyes, his secrets at risk. He paces, the floorboards groaning, and pulls his notebooks. Woolsthorpe's apple, Cambridge's laws, years of quiet refinement. "They'll have it," he mutters, and sits, quill in hand. He rewrites, fluxions sharpening orbits, motion's laws framing gravity's pull. Halley begs, "Give us the book," and Newton nods, reluctant but driven. This is the Principia's birth, rooted in his 20s fire. He works like a man possessed. 1684 stretching into 1685. He forgets meals, his landlady banging, "Mr. Newton, eat." And he grabs bread, distracted. Papers pile, ink stains spread, his cat darting through the flap. He refines the moon's dance, Earth pulls, moon pulls back, tides rise. He maps planets, ellipses bending under the sun, his inverse square a law no one can dodge. Hooke's noise fades, he's got no math, no proof, and Newton grins, sharp and cold. He writes late, candles burning to stubs, his 20s guesses now axioms, a universe pinned to the page. Summer 1686 nears, and the Principia takes shape. 3 books, motion's laws, gravity's reach, a cosmos explained. He stands by the cam one night, the water glinting, and feels it. Woolsthorpe's apple, at 22, sparked this. He'd held it close, through Hooke's taunts, Cambridge's quiet, years of alchemy and faith, waiting for the moment. Halley pushes, the society waits, and in 1687, at 44, it's born. Philosophiae Naturalis Principia Mathematica, his 20s legacy inked forever. He's not the boy under the tree, but that boy's still there, in every line. The real wonder's the ripple. That book launches rockets, tracks stars, binds us to the sun, all from a 20-something's attic. He sits one evening, 1684 fading, the manuscript growing, and tosses an apple from his desk. It thuds, and he smiles. Gravity's his, always was. The narrator chimes in, "This is Newton's Prelude, hit subscribe, because the Principia's next." Chapter 10. Legacy of a Decade. The fire hissed in Isaac Newton's London study on a quiet winter evening in 1705, the air thick with the scent of burning oak and the faint must of old parchment. He was 62 now, a gaunt figure in a velvet robe, his once dark hair silvered, his sharp eyes dimmed but still piercing as they gazed into the flames. The room was a fortress of books and papers, shelves groaning with alchemical tomes, theological tracts, and the worn notebooks of his youth. Beyond the window, the city hummed, its streets lit by lanterns, a world he'd helped shape. On his desk sat a copy of philosophic naturalist Principia Mathematica, its leather cover scuffed from years of handling, published in 1687 when he was 44. But as the firelight danced across its pages, Newton's mind drifted back, not to the book's triumph, but to the decade that birthed it, his 20s, those wild, lonely years from 1665 to 1672, when a plague shut the world and opened his soul. That decade, sparked in Woolsthorpe's attic, was his legacy's root, a fire that still burned in every star, every stone, every step humanity took. He leaned back in his chair, the wood creaking under him, and closed his eyes. He could see it. Woolsthorpe Manor, 1665, the orchard heavy with apples, the attic thick with dust and ideas. He'd been 22, a wiry boy with ink-stained hands, sent home from Cambridge as the plague swept England. The world had crumbled, death carts creaking, bells tolling, but he'd thrived, a loner in a stone farmhouse, pacing under trees, scribbling by candlelight. An apple fell, and he'd wondered, why down? Why not up? That question, so simple, had cracked the universe open. Gravity's pull, a force binding Earth to moon, sun to stars. He'd scribbled it rough then, numbers shaky, but it was there, a seed planted at 22 that'd grow into the Principia's crown. He shifted, the fire popping, and saw the attic again. Prisms glinting, rainbows splashing the walls. He'd split light at 23, a boy with a piece of glass, proving white was a chorus of colors, each bending its own way. The Royal Society had cheered in 1672, Hooke had sneered, but that Woolsthorpe moment echoed. Telescopes sharpened, rainbows explained, a legacy born in a farmhouse. He'd scribbled fluxions too, chasing motion's curve, a language for change that'd lift ships and rockets. 3 laws of motion followed, rest, force, reaction, a skeleton for physics, sketched at 23 while sheep bleated outside. He grinned, a faint curve of his lips. Those years weren't just his, they were the world's, a decade that rewrote reality. Cambridge flickered in his memory, 1667, 24 years old, stepping back through Trinity's gates. The plague had faded, but he'd carried Woolsthorpe's fire, notebooks stuffed with secrets, a mind too restless to quiet. He'd risen fast, fellow at 25, Lucasian professor at 26, his voice a drone to yawning students, his rooms a chaos of papers and furnaces. He'd built that telescope, mirrors beating lenses, and sent it to London, his 20s dream in metal and glass. The Royal Society had crowned him at 29, but Hooke's shadow had loomed, taunts, fights, a rivalry that had scarred his pride. He'd hoarded gravity then, fluxions too, letting them simmer through his 30s, until Halley's knock in 1684 dragged them out. The Principia was their fruit, but his 20s were the soil, wild, raw, unstoppable. He stood, joints creaking, and paced the study, his boots soft on the rug. That decade wasn't easy. He'd been odd, prickly, a boy who'd rather talk to stars than men. He'd forgotten meals, his mother's shouts, "Isaac, eat." A hum he'd ignored. He'd paced till dawn, slept in snatches, woke with ink on his face. Alchemy had burned beside science, Mercury glowing, a quest for nature's soul. Theology had gripped him, Bible pages worn, God's plan a puzzle like orbits. Students had snickered, Hooke had stabbed, but he'd pushed on, a 20-something misfit whose quirks fueled his fire. He'd been alone, but never lonely. Ideas were his kin, the universe his home. The story flows on, Newton's mind a gallery of his 20s as 1705's fire burns low. His 62, knighted now, Sir Isaac, a title he'd shrugged at, but it's the boy of 1665 he sees. Woolsthorpe's attic glows, candle stubs, prism rainbows, apple thuds, a cave where he'd wrestled the cosmos at 22. He'd felt gravity's tug, split light song, ruled motion's dance, all before 30. Cambridge sharpened it, lectures ignored, telescope forged, a chair at 26. The Royal Society tested it, applause in 1672, Hooke's barbs a thorn, but his 20s held firm, a decade that'd outlast them all. He stops pacing, hands clasped behind his back, and thinks of the Principia. Published at 44, it was his peak, laws polished, gravity crowned, fluxions hinted, but its heart was his 20s. Halley had pushed, Hooke had claimed, but Woolsthorpe's apple, at 22, had sparked it. He'd refined it through his 30s, quiet in his rooms, until 1687's ink made it eternal. He sits, flipping its pages, motion skeleton, gravity's web, a universe explained. It's reached the moon by now, rockets would prove it, centuries later, and tracked comets, Halley streaking back in 1758 because he'd said it would. He grins, rare and sharp. His 20s did that, a boy's wonder turned law. The world changed, he sees it dimly, past his window. Ships sail straighter, bridges stand stronger, all from his motion rules. Telescopes pierce the sky, optics his gift at 23. Calculus, fluxions he'd fought Leibniz over, lift science, a tool from his attic nights. He'd been prickly, Hooke's foe, a loner's temper, but that fire drove him. He'd stirred Mercury at 25, mapped prophecy at 27, and tied it to gravity's pull. His 20s weren't tidy, messy, wild, a genius unpolished, but they were his strength, a decade that'd ripple forever. Thanks for joining us on this journey through diverse thoughts, where audiobooks, documentaries, and wild ideas collide. If Newton's 20s moved you, hit that like button, subscribe, and share. The universe keeps spinning, and we've got more stories to chase. Until next time, keep wondering, what's your Apple moment?